ACI P20 compliance protects against inadvertent contact with exposed conductors. However, for National Electric Code 70E purposes, exposed live parts refer to parts that are accessible to unqualified personnel and could cause injury from electrical shock or arc flash. Even if terminal screws are found safe compliant within a panel, they may still be considered exposed live parts if they can be contacted accidentally by opening the panel door or reaching inside through an opening. National Electric Code 70E Table 130.7 C9 assigns hazard category 1 to voltage testing in panels 240 volts or less when using volt-rated gloves and tools. This is because voltage testing involves making intentional contact with conductors, which can create an arc flash hazard if the insulation fails or the tools are not properly rated. A flash hazard analysis is required when performing activities that could generate an arc flash, including voltage testing in panels. The analysis helps determine the potential severity of any arc flash and the appropriate personal protective equipment and work practices to minimize the risk. A hot work permit is required for activities that involve ignition sources, such as torches, or that could create sparks or generate heat, such as welding. Testing a voltmeter in a receptacle is different from voltage testing in a panel because the receptacle is designed to prevent accidental contact with the live parts. Plugging in a computer does not require a hot work permit because the contacts in a receptacle are typically not exposed and are protected by the plug's design. Even though control panels may be IP20 compliant, it is still possible for live parts to be exposed for National Electric Code 70E purposes if they can be contacted accidentally. Voltage testing in panels requires a flash hazard analysis and hot work permit because it involves intentional contact with live parts and could create an arc flash hazard. The analogy to testing a voltmeter in a receptacle or plugging in a computer does not apply because those activities do not involve making intentional contact with live parts or creating an arc flash hazard. Electrical safety is paramount when working with control panels, and understanding the nuances of National Electric Code 70E is crucial for preventing accidents. The primary concern is the potential for arc flash, an explosive release of energy that can cause severe burns and other injuries. Even seemingly minor tasks like voltage testing can pose a risk if not performed correctly. The concept of exposed live parts is central to this discussion. While IP20 compliance offers a degree of protection against accidental contact with conductors, it doesn't fully address the requirements of National Electric Code 70E. Under 70E, an exposed live part is any conductive component that an unqualified person could potentially touch, either directly or indirectly, leading to a shock or arc flash hazard. This means that even if terminal screws are recessed or shielded, they might still be considered exposed if the panel design allows for accidental contact during normal operation or maintenance. National Electric Code 70E Table 130.7 C9 categorizes voltage testing in panels operating at 240 volts or less as a hazard category 1 task, necessitating the use of volt-rated gloves and tools. This requirement stems from the fact that voltage testing inherently involves intentional contact with energized conductors. Any failure in insulation, a faulty tool, or even a momentary lapse in concentration could trigger an arc flash. To mitigate these risks, a flash hazard analysis is essential before commencing any voltage testing. This analysis evaluates the potential arc flash incident energy, which is a measure of the heat energy released during an arc flash event. The incident energy calculation considers factors such as the system voltage, available fault current, and the working distance from the potential arc source. Based on the incident energy, appropriate personal protective equipment, or PPE, is selected. This might include a flame-resistant suit, a face shield or arc flash hood, hearing protection, and leather gloves worn over the volt-rated gloves. A hot work permit is another critical element of electrical safety. It's a formal authorization process that ensures all necessary safety precautions are in place before commencing any potentially hazardous work. The permit typically outlines the specific tasks to be performed, the potential hazards involved, the required PPE, and any other relevant safety procedures. One point of confusion often arises when comparing voltage testing in a control panel to seemingly similar activities like testing a voltmeter at a wall receptacle or plugging in a computer. The key difference lies in the design and intended use of these systems. A wall receptacle is specifically engineered to prevent accidental contact with live parts. The recessed design and insulated housing minimize the risk of shock, even when the plug is partially inserted. Similarly, a computer plug is designed with insulated prongs that shield the user from direct contact with energized conductors. In contrast, voltage testing within a control panel typically requires direct contact with terminal screws or other exposed conductors. This intentional contact, coupled with the potential for higher fault currents, significantly increases the risk of arc flash. Therefore, the safety protocols for these activities differ accordingly. It's important to remember that electrical safety is not just about following rules and regulations, it's about understanding the underlying principles and applying them intelligently to each specific situation. A thorough risk assessment, proper training, and a commitment to safe work practices are essential for preventing electrical accidents and ensuring the well-being of workers. Furthermore, maintaining electrical equipment in good working order is crucial. Regularly inspect panels for signs of damage, corrosion, or loose connections. Ensure that all protective devices, such as circuit breakers and fuses, are properly sized and functioning correctly. Implement a robust lockout-tagout program to prevent accidental energization of equipment during maintenance or repair. By addressing both the technical and human factors involved in electrical work, it is possible to create a safe and productive work environment. This involves not only providing workers with the necessary PPE and training, but also fostering a culture of safety where everyone is empowered to identify and report potential hazards. In addition to the points already discussed, there are several other factors to consider when implementing electrical safety procedures. First, it's important to understand the different types of electrical hazards. These include shock hazards, arc flash hazards, and arc blast hazards. Shock hazards occur when a person comes into contact with an energized conductor and becomes part of an electrical circuit. Arc flash hazards occur when a short circuit creates a high-temperature arc that can cause severe burns. Arc blast hazards occur when the rapid expansion of air caused by an arc flash creates a pressure wave that can cause injuries. Secondly, it's important to select the appropriate PPE for the task. The PPE should be rated for the voltage and current levels that are present in the work environment. It should also be comfortable and allow the worker to perform their task safely and efficiently. Thirdly, it's important to follow safe work practices at all times. These practices include energizing equipment before working on it, using insulated tools, and maintaining a safe working distance from energized conductors. Fourthly, it's important to train workers on the hazards of electricity and the safe work practices that they should follow. The training should be comprehensive and should be tailored to the specific tasks that the workers will be performing. Fifthly, it's important to regularly inspect electrical equipment to ensure that it is in good working order. The inspection should be performed by qualified personnel and should include a visual inspection, an electrical test, and a mechanical test. Sixthly, it's important to document all electrical safety procedures. The documentation should include the procedures themselves, the training records, the inspection records, and any incident reports. Seventhly, it's important to review electrical safety procedures regularly to ensure that they are still effective. The review should be performed by a team of qualified personnel and should consider any changes in the work environment or the electrical equipment. Eighthly, it's important to promote a culture of safety in the workplace. The culture should be one where workers are encouraged to report hazards and where management is committed to providing a safe working environment. Ninthly, it's important to comply with all applicable electrical safety regulations. These regulations are designed to protect workers from the hazards of electricity. Tenthly, it's important to stay up to date on the latest electrical safety technology. This technology can help to improve the safety of the work environment and to prevent electrical accidents. By following these guidelines, it is possible to create a safe and productive work environment for electrical workers. Remember that electrical safety is a shared responsibility and that everyone has a role to play in preventing electrical accidents. The National Fire Protection Association's 70E standard provides comprehensive guidance on electrical safety in the workplace. It covers a wide range of topics, including hazard assessment, personal protective equipment, and safe work practices. Adhering to these standards is essential for minimizing the risk of electrical accidents. Ongoing training and education are also crucial. Electrical technology is constantly evolving, and workers need to stay up to date on the latest safety practices and equipment. Regular refresher courses and hands-on training can help reinforce safe work habits and ensure that workers are prepared to handle any electrical hazards they may encounter. Furthermore, a strong safety culture is essential. This means creating an environment where safety is valued and prioritized at all levels of the organization. Workers should be encouraged to report potential hazards without fear of reprisal, and management should be responsive to their concerns. Regular safety meetings, toolbox talks, and safety audits can help to promote a culture of safety. Finally, it's important to remember that electrical safety is not just about complying with regulations, it's about protecting people. By understanding the hazards of electricity and following safe work practices, it is possible to prevent accidents and injuries. The ultimate goal is to create a work environment where everyone can go home safe at the end of the day. Consider the specific scenario of voltage testing in a 120-volt control panel. While the voltage level may seem relatively low, the potential for arc flash still exists. The available fault current, which is the amount of current that could flow during a short circuit, can be substantial even in a 120-volt system. This means that a small arc flash can still generate a significant amount of heat energy, potentially causing serious burns. Therefore, it's crucial to treat all voltage testing activities with respect, regardless of the voltage level. Always wear appropriate PPE, use properly rated tools, and follow safe work practices. Before commencing any voltage testing, visually inspect the panel for any signs of damage or defects. Look for cracked insulation, loose connections, or any other abnormalities that could increase the risk of electrical shock or arc flash. If any problems are found, do not proceed with the testing until the issues have been resolved by a qualified electrician. When testing the voltmeter itself by inserting the probes into a live 120-volt receptacle, the risk is much lower because the receptacle is designed to prevent accidental contact with live parts. However, it's still important to exercise caution. Use a voltmeter that is properly rated for the voltage level and ensure that the probes are in good condition. Avoid touching the metal parts of the probes while they are in contact with the receptacle. By following these precautions, it is possible to minimize the risk of electrical shock or arc flash.